Same goal. We're going to divide this polynomial. But like anything that you do repetitively, right, you want to make it quicker. And that's what this actually does, is it's going to make the drawing the box and doing the long division seem ridiculously long compared to what we're about to learn. So this is a shorthand for dividing a polynomial by x minus a. So this is my x minus a. This was that p of x, the polynomial I wanted to divide. It's similar to long division, but will only work with the coefficients. So there's a couple steps with this. First step, write the coefficients of p of x in the top row. So what's the coefficient of x squared? X squared's coefficient is 1, right? Coefficient of negative 3x is negative 3, and the coefficient of 2 is 2. All we want are the numbers in front of each term of the polynomial. Write the value of a, this thing up here, in this top left corner. So what you'll need to remember to do with this, we want the actual x value of the x-intercept. That's what we're kind of looking for. So this needs to be a positive one. You need to actually solve that thing. And then I have a little line drawn down here so I can find the answer after this. Then the first coefficient comes straight down, meaning that this is going to be 1. And then to work our way to the end, what we do is we multiply a, and remember a is up here, we multiply a by this number, and we write this below the negative 3. So what is 1 times 1? So we write 1. And then it says to add. Negative 3 plus 1 is negative 2. And repeat until you run out of space. Negative 2 times 1 is negative 2. What is 2 plus negative 2? 0. Believe it or not, we have just divided x squared minus 3x plus 2 by x minus 1, even though it doesn't look like it, right? Now, what happened is we took all the coefficients out of this. We need to put them back in. So the way that I like to draw this notation, I'm going to put a little box around this, because this part right here is the remainder. Meaning that we got a remainder of 0, so we just found out x minus 1 is a factor of x squared minus 3x plus 2, which is probably something we kind of knew before we started, because we know that x squared minus 3x plus 2 is factorable. Then when you go, you have to say, well, okay, well, what do I get when I divide these? First term gets an x to the 0. Next one gets an x squared. If I had more numbers, this pattern would continue. X squared, x to the 3rd, x to the 4th, until you run out of numbers on the top. Meaning that when I did this division, x squared minus 3x plus 2 divided by x minus 1, you're going to get 1x minus 2 as the result. And we could do this longhand and see that. Let's see, we need x squared down here. So we know this needs to be an x. That's minus 1x. That turns into 0. Negative 3 plus 1, that's 2x plus 2. So that means this needs to be, I'm sorry, that's a negative. So that needs to be negative 2. Which will give you negative 2x and a plus 2. And then when we subtract those, we get our remainder of 0, which is what we saw here. And our result was the x minus 2. It's the same thing. It's shorthand. Now, the reason this is going to be important for us is finding factors. So we can find the x-intercepts of large polynomials so we can graph them. is our goal. So we're going to use this method to test potential x values to see if they're x-intercepts, so we can factor polynomials. But let's just try two of these together. So let's go through this setup. The big one is always p of x. This is always x minus a. So when we go to write this down, a goes in the top corner, coefficients on the top. So our coefficients are 1, 1, -9, and -9 from our p of x. What's our a value this time? Is it +1 or -1? -1, because you've got to just do this. Number that goes up top, you've got to take this, what you're dividing by, and solve it. So that means this one's going to be -1. Always pull the first term down, it doesn't change. And then we multiply. 1 times -1 is -1. 1 plus -1 is 0. Then we repeat. 0 times -1 is 0. -9 plus 0 is -9. -9 times -1 is +9. -9 and +9 add together to 0. So is this a factor? Yes, because this number right here stands for the remainder. So that means I found a factor. And what's left over when I'm done with my division, I put these together. So that means if I did this division, I would get x squared plus 0x minus 9. And is it a factor? Yes. X plus 1 is a factor of that big p of x. And now you see why we label the bigger one p of x, because it takes a whole lot less time to write p of x in an answer statement than it does to write all of that out. Let's try the next one. Coefficients. 1, -2, -22, and 40, because this is our p of x this time. Let's figure out our number. We'll solve that. We get 4. Pull our first number down. So that one's 1. 1 times 4 is 4. Now you got to add those two things. -2 plus 4 is +2. 2 times 4 is 8. Add -14. -14 times 4. 56, and it's negative, right? And then when we add these, we get -16. And we run out of space, so we're done. So before we write down the answer, is x minus 4 a factor this time? No. Because we left with a remainder here. This is not a factor. And what we have as our answer, x to the 0, x to the first, x squared. So we get x squared plus 2x minus 14. And then we do have to remember, if we're actually doing division, how to deal with this remainder. You got a plus sign. This number goes on top of your fraction. What you divided by goes on the bottom, which was x minus 4. This follows the same rule that you would do. Let's say we did 3 divided by 10. Does that go in evenly? Is 3 a factor of 10? No, but you can put it in 3 times, right? And we're left with a remainder of 1. How do you write that answer, though? We write the 3 and 1/3, right? Because we have 1 of the 3 left over. The reason we write the plus here, we're actually saying the plus. We say the word and here. What is 2 and 3? 2 and 3 is 5. The word and actually means plus. There should have been a plus symbol in between that in your mixed numbers forever, but we never ever wrote them.